Welcome to another session where we are going to discuss about superposition theorem. Superposition theorem is one among the theorems by applying that you can arrive at the parameters of the network very easily by considering one source at a time. So let us see the objectives of this particular session. So we are going to introduce you what is the superposition theorem and give the statement and explanation of that, and we are going to apply this particular theorem to different circuits, and finally we are going to have a discussion on source conversion technique. There is a technique which is used to convert the voltage source to a current source and current source to a voltage source. So what is this superposition theorem? So very useful theorem because it extends the use of Ohm's law to the circuits that have more than one source. We mainly apply the superposition theorem to a circuit having more than one source. We can calculate the effect of one source by considering that one at a time, by considering one source at a time and neglecting the remaining things. Right? So let us state, in a network of linear resistances containing more than one source, that may be a voltage source or else may be a current source, which flows, the current that which flows at any point is the sum of all the currents which would flow at that point. Each source were considered separately and all the other sources are replaced by their internal resistances. So let us understand one sentence, one word after the other. So the first thing is this statement is applicable, theorem is applicable for a network containing more than one source. So we consider the effect of the first one by neglecting the second one. We consider the second one by neglecting the first one. We add all the currents, we add sum of all the currents by considering one source at a time. So, and the second thing is, let me elaborate the second point with an example in the coming slides. If each source were considered separately, here we consider one source at a time. We don't consider all source at a time. We consider one source at a time. And when we are considering one source, remaining all other sources are replaced by their internal resistances. So these are the four important key points that you have to remember when you are going to state the theorem. It contains more, it is applicable for as a network with more than one source. We consider one source at a time. We see the effect of that by neglecting the other sources, or rather we replace them with their internal resistances. So explanation, this is what is the circuit diagram. Now we know the mesh analysis. Now I apply mesh analysis technique on this and I'll find I1, I2. Now in the same circuit there are two sources are available. I will consider one source at a time. I don't consider this. See, in this circuit, I considered only 6 volts. I didn't consider 12 ohms. Rather, I replaced the source with its internal impedance, that is 1 ohm. The second thing, so I replaced this with its internal impedance. Internal impedance of this is 0, so I replaced that with a short circuit. Here I considered only one source. So what I have done in this is, in the given circuit, I considered one source at a time. Here I consider 6 volts, I didn't consider the other one. Here I consider 12 ohms and I didn't consider the other one. So with 6 volts, the current in this mesh is IA. With 6 volts alone, the current in this mesh is IB. Right? So with 12 volts alone, the current in this mesh ABDA is Ix. The current in this mesh BCDB is Iy. According to superposition theorem, the current which flows at any point is the sum of all the currents which would flow at that point. Each source was considered separately. We considered one source separately and we replace the other sources with their internal impedances. That is clear. Now, according to superposition theorem, this I1 is equals to IA plus Ix. I2 is equal to IB plus Iy. So that is what is the explanation of this theorem. Let us apply this particular theorem to a network consisting of two sources. With one example, we try understanding this. So this is what is the circuit, the previous circuit. So I'm applying KVL in ABDA. I got the first equation. I'm applying KVL in BCDB. I got the second equation. So solving 1 and 2, we got IA value as 1.2, IB as minus 0.8 amperes. Next is, I didn't consider the source 1, I considered only source 2. Now I am applying KVL in ABDA. I got this first equation. Applying KVL in BCDB, I got the second equation. Solving equation number 1 and equation number 2, I got the values of Ix and Iy from this equations 1 and 2. Now according to superposition theorem, I1, if I add Ix and Ia, I will get I1. If I add Iy and Ib, then I will get I2. So after simulating, now you can see the same amount of current is flowing through each and every components, and in this particular mesh I1 is 400 milliamperes and I2 is found to be 1.6 amperes, right? So we see this superposition theorem little more thoroughly with another example. We apply this theorem and we try understanding the source conversion technique also in the next video. Thank you.